Hey everyone, this is a short video to go over the homework from week 2. So I've gone through and drawn in some of the stuff in advance just to help us move through this quickly. I'll also post the final version with everything on so you can see the finished product as well. But let's dive in. The first question, draw a supply and demand graph for tortilla chips in equilibrium, and then suppose that these two things happen. How does that affect your graph? So let me make this a little bit bigger. Supply and demand graph for tortilla chips. I've already drawn the axes here, price on the vertical axis, quantity on the horizontal. I labeled my graph tortilla chips. So now I need my demand curve, right? My downward sloping demand curve. I need my upward sloping supply curve. And then I'll indicate that important point where they cross, the equilibrium, and label the equilibrium price and the equilibrium quantity. So that's the first part, right? Draw a supply and demand graph for tortilla chips in equilibrium. Now, suppose these two things happen and show how it affects your graph. One, it's Super Bowl Sunday. How would that affect the supply or demand for tortilla chips? Well, it probably doesn't have any effect on the supply, but does it affect the demand curve? Well, people tend to get together and have parties, they sit around, they watch the game, they eat snacks. So I'm going to say I think the demand for tortilla chips is going to increase. How do we show an increase in demand? That is a rightward or outward shift. Right? At any given price, the quantity demanded is larger. So we're going to draw this, and I'm going to call this D2 and indicate that there is an increase in demand, an outward shift in demand. Meanwhile, the price of corn, a key ingredient in tortilla chips, increases. Well, what does that do? So if an input price goes up, how does that affect the demand curve? Probably not at all. Right? I don't know what the price of field corn is. Right? I might eat tortilla chips. I don't follow the price of corn, right, going into it. But does that affect the supply curve? Absolutely. Right? As your input prices go up, suppliers are willing to supply a smaller amount at any given price. So you would see a leftward shift of the supply curve, right? A decrease in supply. So we're going to call this S2. Right? And so there is a decrease in supply. And ultimately, the equilibrium price and quantity, what happens to it? Well, you know the equilibrium price is going to go up. If you shift the demand curve out and the supply curve back, you're going to end up at a higher price. So we'll call this E2. Label this P2, right? There's your higher price. And in my graph, the way I drew it, Q2 is also greater, right? So we see that the price goes up. And in my graph, I see that the quantity goes up. But your graph could look different, right? This depends on the magnitude of the shifts, right? So just suppose, what if you had drawn in supply 2 to look like this? It's hard to see that, isn't it? Let's pick a different color. Sorry about that. What if you had drawn supply 2 to look like this? I don't know, I'll call this supply 2 prime, right? It looks like a 1. That's sort of a confusing way to do it, probably. But if you had done this, then you would be here at the G in ingredient, and you would have had a still higher price, but your quantity demanded would have been lower, right? The equilibrium quantity would have been lower than before. So the price has to go up. The equilibrium quantity could go up, it could go down, it could end up staying the same, right? What if you had drawn a supply curve that went through right there and you had exactly the same supply? So that all depends on the magnitude of the shifts. Don't worry too much about that. Oh, I took out the T in tortilla, didn't I? My bad. We can fix that though. There we go. So don't worry too much about that, like whether yours is larger or smaller. It could be either way. It depends on how you drew the graph, but the price has to go up. And so ultimately, I mean, you could even note this if you wanted to. You certainly didn't have to for this question. But what happens to equilibrium price and quantity? The price in equilibrium has to go up. The quantity in equilibrium could go up, down, or stay the same. Right? So that's sort of as an aside there. But that's the important things here. Oh, I wiped out my demand. I knew something else was missing. wiped out my demand curve here too. There we go. Now we fixed it. So demand should shift to the right, supply should shift to the left, and then your new equilibrium falls where it does. So that's the first question. That's worth 20 points. It's broken down, for overall setup and then shifting the curves. Okay, I keep wanting to say, all right, any questions? Y'all understand, but this is kind of a one-way video, right? If you have questions, you absolutely can email me. We can set up a time to chat. But I can't hear them right now. Okay, question 2. Draw a demand curve for ballpoint ink pens that evidences a high sensitivity to price. All right, a high sensitivity to price. What does that mean? That you're very, very sensitive to price. Is that elastic demand or inelastic demand? Well, a high sensitivity to price, that means you're going to be very sensitive. A little change in price leads to a big change in quantity demanded, right? That's very elastic. And so how do I draw a highly elastic demand curve? Well, that's going to be fairly flat. Right, so there's my demand for blue ballpoint pens. Notice I already drew the setup, right? Price, quantity, labeled my graph, shares the origin. Now add a supply curve to the graph as well. So we'll add in a supply curve. Here's my initial equilibrium. If a natural disaster disrupts production and causes the supply to decrease, how does this affect the quantity sold? In what direction does the quantity change and by how much? So here, let's do a different color for this. Natural disaster interrupts the production, and so it causes the supply to shift which way? Disrupts production, it causes the supply to decrease. I even gave it to you here. So let's show a decrease in supply. Right, that is a leftward shift. And then what happens to the quantity of ink pens? Well, it goes down by a lot, right? So the new equilibrium, the price goes up a little bit, and the amount sold goes down a lot. So that's it, right? What direction does the quantity change and by how much? The quantity sold goes down, and it goes down a good bit. Got to be careful. Even when I pre-draw these, I lose my... That's close enough. There we go. Now what was I trying to draw? I was trying to show this, right? A little neater. There we go. So there you go. Leftward shift in the supply curve, very elastic demand curve, so that demand curve should look fairly flat. Then you show the change, shift the supply curve, new equilibrium, decrease in the quantity sold. That's question 2. Number 3, assume that apples are an inferior good. Now, this system's got several parts, right? Assume that apples and oranges are substitutes, that apples and caramel are complements. What will happen to the demand or quantity demanded for apples if the price of oranges decreases and the income of people who buy apples increases and the price of caramel increases, right? So we got a lot of stuff going on here all at the same time. So let's start with the supply and demand graph itself. Wish I had left a little more space for this one, right? Because this is got a lot of things. So here's the demand for apples, right? I already labeled price, quantity, labeled my graph. There's the supply of apples. This is my initial starting point. And so we're going to label the equilibrium quantity and the equilibrium price. So there's our starting point. Now, let me do this in colors, in a couple different colors so you can see it happening step by step. Price of oranges decreases. Let's start with that. The price of oranges decrease. Now, and remember, the apples and oranges are substitutes. So if the price of oranges goes down, what happens to the quantity of oranges sold? Well, that's just a movement along the demand curve for oranges, right? They sell more of those. As people are buying more oranges, what happens to the demand for apples? Right? So if oranges get cheaper, right, price of oranges decreases, then people will buy more oranges. They'll substitute towards oranges and they'll buy less or fewer apples, right? So if the price of a substitute goes down, you'd expect that to decrease the demand for apples. So I'm going to enlarge this a little bit. And call this D2. Right? So there's the first thing that happens. I'm going to color codes and see. Price of oranges goes down, that leads to a decrease in demand. Now, what happens if the income of the people who buy apples increases? Well, if the income of people who buy apples increases, what happens to the demand? As people have more money here, let's make that green since that's an income thing. Income of people who buy apples increases. So if they have more money, then their demand for all normal goods goes up. I didn't specifically tell you that apples were a normal good, but let's suppose that they are. So then from D2, that's going to cause an increase in demand, right? So you'd expect to see demand increase. Now, will it increase more or less than it did before? I don't know. I'm going to shift it out to here. So we'll call this D3. Now, your D3 could be right back to where original demand was. It could be a little bit less than original demand. That just depends on the magnitude of the shifts, right? This is just to show you lots of things can happen at the same time. Income people buy apples increases, and now the price of caramel increases. So let's pick another color for caramel. We'll make this pink. If the price of caramel increases, and apples and caramel are complements, so if the price of caramel goes up, people buy less caramel, right? That's just the law of demand. At a higher price, people buy less of it. So think about the demand curve for caramel. Higher price, people buy less caramel. If people are buying less caramel, what happens to the demand for a complementary good? Well, then it goes down. So from D3, you're going to see a decrease in demand. So we'll call this D4. So in my graph, I ended up here at a price that's a little bit lower and a quantity that's a little bit lower as well. But yours could look different. It all depends on the magnitude of the shifts. What I want to see is that price of caramel increases. What I want to see is that an increase in the price of caramel leads to a decrease in the demand for apples, right? And that if then the price of oranges goes up, that similarly leads to a decrease in the a decrease in the demand for apples. I didn't label this, did I? Decrease in the demand for apples. And that increase in income, right? If people's income goes up, and if apples are a normal good, then that leads to an increase in the demand for apples. I won't normally put all of these together in one problem, but it was sort of just get you thinking about them all at once here, that the demand for apples goes up. So where does it ultimately end up? I can't tell you. There's not enough information here to say which of these effects are stronger than the others, but those are the directions the curve should shift. So there you go. That's number 3. Now, some of these next ones are a little more mechanical, and so some of them are, fairly straightforward. So the price elasticity of demand is -5 if a 10% increase in the price results in a blank decrease in the quantity demanded. All right, so this just gives it to you a different way. Normally, in many of the examples, you get the percentage change in price and the percentage change in quantity demanded. You need to know where to put them. Right, so it's the percentage change in quantity demanded over the percentage change in price, and that gives you the price elasticity of demand. Here's a 10% increase in the price. Right, so that goes in the denominator, right? There's plus 10. And then you need the numerator is the percentage change in quantity demanded, except I don't know that. That's my variable, right? What they do tell you, though, is the answer. It's going to be -5. So then the question is, what do you have to put in here? So put X up here and then oops, what happened there? Call this X, or X is your decrease in quantity demanded. What is it divided by 10 gives you -5. So you can use algebra and multiply both sides by 10, and you'd get X equals -50, right? So, and that would make sense, right? Because -50 over +10 equals -5. It's an equal sign there. So, what we need, the decrease in the quantity demanded has got to be 50%. That's what would give you a -5 for your price elasticity demand. That is very elastic, right? Highly sensitive to price. So that's all there is for that one. The next one, this one requires some calculation, and this requires using the midpoint formula, right? So use the midpoint method, but it's still, now this is price elasticity of supply, right? So remember the expression for price elasticity of supply, percentage change in quantity supplied over the percentage change in price. So here's my change in price. It goes from 600 to 750, except now in this case you have to actually calculate it, and I tell you to use the midpoint method. So price goes up from 600 to 750. That's an increase of 150. And then, traditionally you divide by the starting value, but using the midpoint method, you divide by the average of the two values. So 600 and 750, the average, right, the midpoint of those two values is what, 675. So the increase in price is 150 divided by 675, and that gives me 22%, 0.22. That says 675. I'm not sure if that was very neat. Try that again. Tell you what, I'll make it bigger. That's a little better. Right, so the percentage change in price is 22%. So actually in the overall thing, right, we can put the plus 22 down here, right, when we're calculating price elasticity of supply. But now we need to see what happened to the quantity demanded. So when the price went from, to the quantity supplied, when the price went from 600 to 750, I got sloppy there. Hang on. I was in my head when I was sort of pre-drawing this, I was thinking quantity supplied. This is price elasticity of supply. And when the price goes from 600 to 750, the quantity supplied goes from 18K to 24,000. Right? So I gotta fix this too. The quantity supplied goes up. Sorry about that. The quantity supply increases, right? Because when you go from 600 to 750, the quantity supplied increases, goes from 18,000 to 24,000. So what is that? That's an increase of 6,000. Well, we can write it out just to be clear. Over the midpoint of 18,000 and 24,000. So what is that? The middle of that is 21,000. So basically you get 6 divided by 21, and that gives me 29%. I'm using an old financial calculator which automatically rounds to 2 decimal points. It probably is. Let me check this. Use my phone here. 6,000, 6 divided by 21. Yeah, 0.2857. So that's pretty close. So that equals we'll call it 0.29 because that's what I did before. That's a little bit sloppy. That's my bad. So it goes up by 29%. And so if we put 29% over the 22%, we get 29 divided by 22, 1.32. Now, if you had brought along a couple more decimal points and didn't round to 22% and 29%, you might get something, slightly different in the last digit there. But that's close enough for our purposes. The price elasticity of supply in this case would be 1.32. So that's a 10-point question because it requires you to know the formula, put these in the right order and calculate it, but also to get the 29% and the 22% from the values up here in the table. So there you go. That's number 5. Number 6, this is more about interpretation. Here's, I found some values and from a, in a textbook. Copy those in here for you. Now, you should always have a healthy amount of skepticism, for where the data came from, because this is a quantitative thing. Our data is not always perfect, and so I have some questions about some of these numbers. I think they're interesting, and then part of me is like, is that really the case? But let's look. In the first part, what does the price elasticity of demand for paper towels mean? Is the demand for paper towels elastic or inelastic? Well, I circled it here, and the paper towels is third from the bottom. It's minus 0.05. What does that mean? Is that elastic or inelastic? Is that price elasticity of demand elastic or inelastic? Oh, it's inelastic. It's very, very inelastic. It is not very sensitive to price at all, right? So if price of paper towels goes up 10%, sales go down by only 0.5 of 1%, 0.5%. Because think about it, if the price of paper towels goes up by 10%, then the sales go down by some amount such that when you divide it, you get 0.5. So the answer to that has to be 0.5 divided by 10. Yeah. To get 0.05. So you have to have just 0.5% to start with, right, if you solve for x. So what that means is if the price of paper towels goes up by 10%, people's consumption of paper towels goes down by only 0.5%. That seems really, really small to me. So that means the demand for paper towels is highly inelastic. And what would cause that? Well, the primary thing that would cause that would be a lack of close substitutes. So people act as if, right, people purchase paper towels as if there are no good substitutes. And as I think about it, there aren't, a lot of close substitutes, but there are other things. And you can use, in our kitchen, we could use fewer paper towels if we used more dish towels, right? So, or old rags, right? So, you may use dish towels to dry the dishes and wipe up at the counter sometimes. But that spill on the floor, we'd use a paper towel. But could we use an old rag and then wash it, and use it again? Sure. So I don't know. I just think that's very, very small and highly inelastic. I think that's especially interesting given that toilet paper is also on this list. And toilet paper is minus 2.42, which is much more elastic, right? People are much more sensitive about toilet paper. And I'm curious, what are the good substitutes for toilet paper? What makes toilet paper so much more substitutable than paper towels? That's what causes me to look at this list and say, that's interesting. Now, being prudent, or careful or with your toilet paper, not wasting it, not balling up huge gobs, I suppose that's a substitute, right? Using it more judiciously. And when the price goes up, people may do more of that. You can install a bidet, right? That's a substitute for toilet paper, on some margin. But I don't know. I just thought that was interesting that the demand for paper towels, at least according to this information, is so inelastic, and that the demand for toilet paper is fairly elastic. Thought that was interesting. Next question on the list here. How can you explain the difference in price elasticity of demand between soft drinks and dish detergent? So here, the blue line over here, I sort of highlighted soft drinks is up here at minus 3.18, and dish detergent is down here at minus 0.74. So soft drinks fairly elastic, dish detergent technically inelastic, right? Absolute value less than 1. This makes sense to me, right? These values seem logical because there's a lot more substitutes for soft drinks than there is for dish detergent, and yet people still respond, some to the price of dish detergent. So that all seems to make sense to me. But in terms of the surprise, this question, does anything surprise you? That's just to get you thinking about it. But like dish detergent, soft drinks, that doesn't surprise me. But paper towels and toilet paper, that does. But that's just me. You could have looked at anything on here and thought about it and put something down. So last couple, almost done here. Number 7, income elasticity of demand for eggs is minus 0.71. Right. So now this is income elasticity of demand, price or percentage change in quantity demanded over a percentage change in income. So what does this tell you? Well, the minus 0.71, the negative value here, tells you that it's an inferior good. Right. As income goes up, sales of eggs goes down. So quantity of eggs sold goes down. That is, that's interesting. That negative value is what tells us, suggests that this is an inferior good. And the last one, this is a cross price elasticity of demand question. If cable TV prices go up 10% and phone-based DSL internet access goes up 4%, what is the cross price elasticity of demand? What does that tell you about cable TV and DSL? So you look at the 10% increase in price that goes in the denominator, that's the price of cable. The 4% increase in DSL sales, that goes in the numerator, right? So it's the change in price of one good and the change in sales of the other good. That gives you 4% over 10%, that gives you 0.4. That's a positive value, and that positive value is what tells you that those two goods are function as substitutes in the consumer's eyes. So there you go. That is the whole thing. And if you have questions, you can follow up with me. And I had initially laid this out one way, but hang on. I'm gonna rejigger this. I had initially not given any points for this surprises you part, but I'm gonna do that. We're gonna shift some points up, 5 points up there. So just if you thought about it and wrote something down there, then you get those 5 points. And this one, even though it had 2 parts, a calculation and an interpretation, it's still fairly straightforward. So we'll make that just 5. So there's the final rubric with the point values on the left. And my answers, I will post this document for you, and then you'll have this video, right, that you're watching now to go over it. That's it for homework for week 2. Follow up with